Salad sharks, I like them. Right, let's head on to another very interesting presentation. E Santos from Oceanography is giving us a very nice talk about the reproduction of Port Jackson shark. I was lucky to see this presentation already in Atlanta, and I think I can say that the American colleagues were impressed also by the quality of this presentation. So enjoy the next talk and
Thanks, Paul. Hello, everybody. This is a big responsibility now. Yes, I'm going to talk with you about the reproduction of Heterodontus portaxoni at our institution. We have this species since 1998, although we were able to reproduce them only in 2011. When we decided to play with one of the physical parameters to see what would happen, we had very good results, and that's what I'm going to show you. So the Heterodontus portaxoni is known as the Port Jackson shark. There are about 8 different species that belong to this genus. So they can be found in the southern waters of Australia. It's an oviparous species with this particular kind of egg case is very, very nice. The females lay around 10 to 16 eggs per season. Normally they lay the eggs in pairs. It takes around 12 months for the incubation, but of course it depends on the temperature. The females, they get sexual mature around to 11, 14 years old when they get the size of 80 centimeters to 95. The males are a little bit smaller, and they get sexual mature early when they get 8 to 10 years old with the 70 to 80 centimeters total length. The breeding season, it's not a surprise. Normally, like all other species, starts in the end of winter, beginning of spring. Normally the males are found together, but the females are found together, but the males are apart. So they have to swim during the breeding seasons. The males have to swim to find the females and mate with them, which can be quite aggressive as other species of elasmobranchs. So, as I told you, we have since the species since 1998. First we started with 2 females, and then in 2000 we got two males, 2 juvenile males. Our females, they become sexual mature in 2005 when they started to lay the first eggs. But the males only got sexual mature around 2009 because it was more or less by that time that they got the adult size. But okay, this is the tank where we have the Heterodontus, the Port Jackson. It's a 21 cubic meter aquarium. It's a closed system, and it's a community aquarium with species from all species from the southern waters of Australia. So until 2011 we had a lot of eggs, but no viable eggs, and there was no signs of mating. And we were thinking about that, what would be the problem. We had that tank at a stable temperature of 15 degrees all year around. And because there are a breeding season with temperature variations, that could be one of the issues for the lack of breeding behavior. So we decided to, okay, let's change temperature and see what would happen. So, but what would be the best temperature limits? So studying the annual temperature in the 3 cities of Australia where we can find the Port Jackson sharks, we found the best temperature limiters, but we had to take in consideration the other species in the aquarium. So we created our own temperature cycle with a minimum of 13 degrees and a maximum of 20 degrees. And we started to change temperature 19 May of 2011. So there was another question that was now mine. All the eggs that we collected, we placed them in a box connected to the aquarium in a vertical position, because we knew that in the wild, the females normally, when they lay the eggs, they grab the eggs and they place the eggs into crevices, which means that some of the eggs will stay in the vertical position. But we spoke with our colleagues from the Arctic Zoo, and they had success breeding the Heterodontus franciscis, placing the eggs in the horizontal position. So, okay, let's do it. Let's change all our eggs from the vertical to the horizontal position and see what will happen. And it was amazing because since we started to change temperature, we started to see our first breeding behavior, with the females showing up with some wounds in the fins and in the body, and also with some morphological changes in the clasper of the males. Here you can see a relation between the number of eggs and the temperature. Until we started changing temperature, our females were laying eggs all year around. After we started to change temperature, there was, at a certain point, the female just stopped to lay the eggs. But as you can see, they stopped to lay the eggs when the temperature was increasing, which is quite interesting because it's the opposite that happens in the nature. But we can speak later on about it. So, as we started to change temperature, we got our first fertilized egg in November, and then the second and the third in January. Unfortunately, we lost the first one, but we kept the other two. So all the eggs were monitored at the first point by ultrasound, which allow us to separate the fertile from the unfertile eggs, of course, and also monitor the embryo development after that. Here you can see some pictures of unfertile eggs with no yolks, no yolk sac, or with some atypical yolk sac or the yolk sac, but with no visible embryo, or with our embryos, our first embryos. These pictures were given us by Kate Ronda. It's the same species. It's a projection with the same ages that ours. Let me see if this runs. I will just show you what it says here. Maybe okay? Okay. Thank you. So this is, at the same time we took pictures and we filmed it. So we can see the yolk sac. 2 months after that, we saw our embryo moving. As you can imagine, it was really exciting. And this is with 4 months. Can you see it moving? I don't need to. Good. And now it's with 8 months. You can see the mouth. You also can see the eyes. The dorsal fin, the lateral fin. I have to. Well, you see it's turning upside down. So during this time we were checking the size of the yolk sac, because that was one of the principal ways for us to see how is it growing, if it's reaching the hatching time or not. At a certain point, around 8 months, the egg case will open in both sides to let the water get in the egg. So at that time, we start to use endoscopy. And use those openings to put the endoscope and have a clear and closer check on the structures. Here are different stages of the yolk sac development, and here different parts of the embryo, like the mouth, the spine on the dorsal fin. This is the lateral head, the eye, and the claspers, because one it's a male. So as I told you, we knew that it would take around 12 months for the incubation. And we also had spoke with Kate Ronda, a student from Australia, and she did a PhD studied the embryonic development in Port Jackson shark at lab condition, with embryos hatching at 400 days at 18 degrees and after 300 days at 22. So our temperature was lower than the 18 degrees. So we knew that would take a little bit more than 400 days. But how long it would take, that's why we were always checking the development by ultrasound endoscopy. And at the same time, we were taking different measurements, like the size of the head, the yolk sac height, and the yolk sac width. And at a certain point, as you can see, there was no decreasing anymore at the yolk sac. So that either in width or either in the height. So that meant that the embryo was not feeding by that yolk. So we know that they have also an internal yolk sac, but that we could not monitor. So this one was for us the best time to see, okay, maybe it's time for them to hatch. We also had, from the help of our colleagues from the Artizu, that in captivity, this kind of egg, sorry, take the sound out. We also knew that in captivity, these species cannot leave the eggs by themselves. The egg cases are too thick for them to hatch by themselves, so they need to be taken out from the egg. From the measurements taken by the ultrasound, showing that the yolk sac was not decreasing anymore. We had our first egg when we decided to take the juvenile from the egg at about 425 days. So we think, okay, it's time to do something, let's take them out, and that's what I'm showing you. As you could see in the beginning, it was quite hard to cut the egg case because it was really thick. It's completely rolled inside the egg case. I just took the sound because you will see everybody screaming, which is, oh, we did it, we did it. And the pumps, it's too noisy. So there he goes, slowly. We're trying to take almost. As you can imagine, he spent more than 1 year inside that egg case. Is completely like crazy. It's like a big ocean now. He doesn't have any references, any orientation. So it took quite a few minutes for this tiny little one find the, whoops, there he goes. Where am I? Almost. And after a couple of minutes, he finally got to the right position. Almost there. And there he goes. Tired, of course, but he's okay. So here you can see the residual yolk sac, and they're born with around 19 to 20 centimeters long. So after 2 to 5 days of birth, we started to force them to feed. We didn't know, we tried to give them food, but they didn't eat anything, so we tried to force them to feed. But that didn't work. The animals were very stressed, so we decided to stop it, and we decided to keep trying to feed them with a stick. And that resulted after 3 days in the males and 10 days in the females. In the female, they started to eat. There we go, offering squid. That's what they both first started to eat. Smelling and then, oh, this is good. Yum, yum, yum. Interesting is, oh, this is good. And they were both looking at you. It was not on purpose, they really did that. And there he goes. And after that, we feed them daily. For the first 3 months, we feed them 2 times a day. We feed them a certain amount. Well, we feed them ad libitum, but then we weigh how much they had. During the first 3 months, we feed them twice a day, but after that, we thought it was too much because they were not increasing in the proportion of what they were eating. So we just fed them once a day since then, and they are growing quite well. We feed them different kinds of foods like shrimp, squid, and different types of fish, and so on. Normally, they eat around 2 to 5% of the body weight. We keep them separately from the tank where the adults are, because we're still doing the annual cycle temperature. And we keep them, these ones, we keep them at a constant temperature of 19 degrees. They're born with around 70 grams, and now they have about half a kilo. So as you can see in the graphic, they are growing quite well. And now we have another egg, also with the embryo growing. Just hope that it's also hatched, and they have very good results at this one. And we'd like to thank to everybody that somehow helped us to do this presentation. Thank you.
Thank you, Elsa. Are there any questions? Right. Can you? Several?
Thank you, Mr. Wick.
Thanks, Peter.
How did you control the temperature? Was it a manual process, or did you automate it in some way?
In the tank, the adult tanks?
Yes.
Because it's a closed system, everything is controlled by the computer, and we establish what are the limits for the temperature.
Okay, so that was an active process where you would say, well, we could reduce by half a degree this month.
Yes.
Okay,
yes.
Perfect. Thank you.
Okay, thank you.
Pino, just next to you.
Please.
I'm just interested in who is opening the eggs in nature. Is there anything known about it?
Sorry?
Who is opening the eggs in the ocean?
There's maybe Eugene can help me answer that, because
we
he did
research back in Amsterdam on this, and we got some eggs from California, and they are worn out. They are being eaten by lots of little critters, isopods. They are rolling around on the seafloor. We did electron microscopy on the eggshells, and they were in California much thinner than in our clean tanks, and they are completely whole like when they were deposited. So they hatch themselves.
That was my question.
Oh, right, okay. Okay, thank you.